Trinity Maths. Solve problems using Pythagoras theorem. This is our destination. How do we get there? Close the Excel file. From Trinity Maths, select Geometry, Open, Solve problems using Pythagoras theorem. This is a macros-enabled Excel spreadsheet, and I'm looking for find horizontal distance x of a plane from a radar given altitude a. This is an interactive accurate scale diagram which represents a plane approaching a radar. I have dynamic control of altitude a the plane flies at, and line of sight diagonal d of the plane from the radar, which I can increase or decrease. We were given starting conditions, but I'm going to create a new scenario with altitude a equals 8.5 and diagonal d equals 10.5. Ask your pupils, can you find the plane's horizontal distance x from the radar by algebraic methods? Before we do any maths, we can see from the diagram our answer is expected to be somewhere between 6 and 7 kilometers. Using Pythagoras theorem and paying close attention to the three given labels on the diagram gives the relationship d squared equals x squared plus a squared. We want x, so rearranging this gives x squared equals d squared, subtract a squared. Sub in the known values 10.5 and 8.5. Evaluate the square of each measurement, then find the difference between them. Finally, find the square root of both sides. We reach for our calculators, and here's our answer to 9 decimal places, which gives the value x equals 6.2. Don't forget the units and state the degree of accuracy. As predicted, our answer is indeed somewhere between 6 and 7. Now this is all very procedural, developing our pupils' fluency, but how can I introduce an element of reasoning or problem solving into this activity? Let's reset the screen but reveal the answer and increase the altitude to 10.5. I'm now going to hide the diagonal d and then increase it until the value of x is exactly 3.6. The reason this has become an exact value is we now have a right-angled triangle which is a multiple of a primitive Pythagorean triple. Our pupils will now have to use a different calculation method to the one we just performed to find the unknown line of sight diagonal d. Since we now have to find the longest side or hypotenuse of this right-angled triangle, the two values must be squared, then added, and then this sum will be square rooted. Your pupils should find after performing this new calculation, they get the value d equals 11.1. Let's check this by performing the procedural calculation once again. And this checks out. At the introduction, I stated this is an interactive, accurate scale diagram which represents a plane approaching a radar. We can see on the scale diagram that all three of these new distances are shown as true to scale measurements. As an enrichment exercise, you might encourage your pupils to find an approximate solution to this problem by a scale drawing method using a pencil and a ruler and a pair of compasses.